Okay, hello. So today we're looking at question 430, flatten a multi-level doubly linked list. Given a multi-level doubly linked list, we are supposed to basically flatten the list so all the nodes appear in a single level doubly linked list. So what they mean by the doubly linked list they've given us is they've shown it in a diagram over here. So as we can see, there are a few levels to it. So each node may or may not contain a child pointer that is pointing to another level's doubly linked list. So in this example, we can see that, is this too small? Maybe I should enlarge it. Is it possible? Oh, okay, there we go. So in this example, we can see that like we have like 3 levels, 1, 2, 3, and that this child pointer at this node 3 is pointing to the next levels, and node 8 has a child pointer pointing to the next level, node 11, and yep, our job is to basically flatten everything to output this 1, 2, 3, 7, 8, 11, 12, 9, 10, 4, 5, 6 instead. So how do we get this output is by going down by the child pointer first before we look at the next nodes. So it is kind of like a depth first search, traversal. So we can see we go 1, and then we go 2, and then 3, and then we see a node with a child node. So next we do 7 instead. I feel like I'm not drawing this right. Hang on, let me try it another way. Okay, so we go 1, and then we go 2, and then we go 3, and then because there's a child pointer, we go down 7, and no child pointer, so we continue 8. We hit a node with a child pointer, so we go down at 11, and then no child pointer, so we go 12. And as you can see here, it's what we outlined is this part so far, right? 1, 2, 3, 7, 8, 11, 12. And then remember how we didn't visit the next pointer of this node 8 because we went down because it has a child pointer. So we're going to go back to node 9 and 10 and go back up to our 4, 5, 6. So this to solve for this question, we'll need a stack to kind of like keep track of the stuff that we haven't visited and processed yet. So what we need to do is basically, let me zoom out a little and move to the right. Yeah, okay, there we go. Basically have a stack, and what we can do is we keep popping elements that we've already visited and then pushing on to the stack, like the next node first, followed by the child node, and then we keep popping off the top of the stack. So like the flow will go something like, first we have push 1, and then we pop it to kind of like examine it, right? So it has a next pointer pointing to the node 2, but it doesn't have a child pointer, so we push 2 on the stack, and then we pop 2, and then we push the node 2's next and child onto the stack. Since it doesn't have a child, we push the next node onto the stack. We find that 3 has a a next pointer and a child pointer, right? So pop 3 to process it, kind of like visit it in a sense. So we pop on the 4 and like we said 7 now, because we want to like visit the child node first, right? So now that we have this on the stack, we pop the topmost 7 off the stack because it's on top, and what we do is we push on 8, pop 8. What we get is we'll push on 11. We push on the next first, right? So we push on 9 first, and then we push the child node 11, and now we process 11, so pop that off and process 12, and then pop 12 off. Okay, now we want to go process like node 9 because we haven't visited that node yet, so we pop 9 off, push 10, yeah, and then 10, we're at the end of the doubly linked list on this level, so we pop that off, and the stack's not empty yet, so we pop we pop 4 finally to push 5, and then pop 5 to visit 6, and finally pop 6, and we're done, and we can return our solution. So that's basically the rough idea. Let's try implementing it now. So after we pop the nodes, right, like off the stack, we have to remember to kind of like process it in a sense to link the previous pointers and the next pointers to the correct positions, and also remember to set child pointer to none, because the final linked list is single leveled. So let's just quickly look at the constraints. Number of nodes will not exceed 1,000, and node values ranges from 1 to 10 to the power of 5. Okay, so let's initialize a few things. We definitely need, okay, let's look back at the diagram. So what we need for sure is our stack, right? So that comes first, and we want to like start it off with like the head node, the first node, right? And then we also need a previous node pointer, because initialize it to a dummy value, because we want to like point use that the previous node pointer to kind of like point to our previous node, so our current node can like the current nodes.next can point to the previous node. Current nodes.next pointer can point to the previous node. Yeah, that's right. So node and value, we just initialize to 0, none, none, none. Yeah, that looks right. So while stack is, still not empty, what we want to do is, first pop things to like visit it and analyze it in a sense. So my stack dot pop. Right, once we've popped it, if it has a next, we wanna like push it onto the stack first before we check if it has a child, and then we push it onto the stack later, so the child is on top of the next node. So we process like the child node first. So my stack, my node dot current node dot next. So we now push my stack dot append current node dot next if current node dot child my stack dot append current node dot child. Oh. And then what? Okay, now we need to like do the rerouting. Can I call it that? Like rewiring, I suppose. What do we need to do first? So previous nodes dot next has to point to the current node, and then current nodes dot previous has to point to the previous node, and then current nodes dot child is equal to none, and previous node is, we want to move it up like to the current node. Okay, I think that is all. And then at the end of it, we want to make sure head dot previous is set to none, and we return the head. Okay, let's check. Oh, okay, sweet. Let's try running it. Okay, so we need to handle the case where the linked list is empty. So if not hit, turn hit. Okay, sweet. So that's it for today's video. Thank you for watching.